Grade 8s, welcome back to the masterclass on Pythagoras. So today I'm going to be explaining to you how we can take the information that we've learned prior to this video about triangles and take it onto the board where we can solve something like this. Now, we need to solve for D. That doesn't seem like we are able to do this using the knowledge we know about triangles. Now, what do we know about triangles? Well, the information about triangles that we need to understand in order to get to something like this is how do we identify triangles? Now, the identification of triangles is always done through lengths of sides or an angle, like a right angle. So we've got an isosceles triangle where we have two sides that are equal in length, and that's shown to us in a diagram. Then we've got a scalene triangle, which is the odd one out. It's the one that has three sides that are all different in length. And the other one that we have is a equilateral triangle where all the sides are equal, which then means that all the interior angles are the same, all 60 degrees. And the other one, which we're going to use today, is the right angle triangle. And that's when we have this little box in the corner of a triangle. So what we're going to do is, I'm going to explain to you how we can actually solve something like D. So let's get to it. Alright, so on the board I've drawn three right-angled triangles. Now with Pythagoras, there's a theory that this bright and intelligent man from Greece came up with. And before we get to any of that sort of in-depth formula, I need to explain to you what we need to understand about a right-angled triangle. Now things that we haven't heard before are things like a hypotenuse. Let me put this in blue. Hypotenuse, the word hypotenuse. Right, now what is a hypotenuse? An hypotenuse is the longest side of a right angled triangle. And how do we identify it? Often people will say, well, it's just the longest side of a triangle. So I don't quite like to use that because often when we are given diagrams in a maths test, we can't take things for what they look like. We have to take them for what they actually are, using the symbols that maths teachers put onto a triangle to indicate that it's an isosceles, indication of two sides that are equal in length. They put the two marks on. So what I'm trying to say to you is that we cannot just go with that. We have to know for sure. So as indicated, all three of these are right-angled triangles. How do I identify the hypotenuse? Well, the formula, or the way that I like to do is, it's always opposite the right angle. So this would be my hypotenuse. BC or CB would be my hypotenuse. What would be the hypotenuse over here? Again, BC. Why? Because it's opposite my right angle. And again, in this last example, where is my hypotenuse? It is opposite my right angle. So this would be called my hypotenuse. That's why hype for short, just so we can get through this. But that's my hypotenuse, and that is my hypotenuse over there. That's very, very important. Alright, when we're dealing with this whole theorem that I'm about to tell you. So, what did this wise man actually tell us? He says that if we square the hypotenuse, alright, if we square the hypotenuse, he says, so let me just draw, I'll bring this one down here. If we square the hypotenuse, and I'll draw another right angle triangle in here. Now it's a right angle triangle, so the box is there. And we've got, we'll start from the top here, A, B, C. He says that if we square the hypotenuse, so where is my hypotenuse? My hypotenuse is opposite my right angle. If we square the hypotenuse, so AC squared, he says the hypotenuse squared is equal to the sum of the two shorter sides squared. Sum, what does sum mean? Sum means addition. Sum means plus. We are adding when they use the word sum. So he says it's equal to the sum of the two shorter sides squared, which is AB squared plus BC squared. And that's his theorem. And that is proven using right-angled triangles. Pythagoras is only used if we have right-angled triangles. So just recapping on what I've told you now, alright? The Theorem of Pythagoras states that if we have a right-angled triangle, if the block is there, alright, the hypotenuse, which is found opposite my right angle, my hypotenuse squared, is equal to the sum, addition, the adding of the two shorter sides squared. So that's it in a nutshell, all right? So let's move on to what we want to know if we actually have numbers. So if I had to add numbers here, and I said that the length, all right, of BC was 4 centimeters, and I said the length of AB was 3 centimeters. Now, I'm going to mimic, I'm just going to copy exactly what I wrote down over here, because what am I left out? What side am I looking for? I'm looking for AC. What do we know about AC in this right-angled triangle? We know that AC is the hypotenuse. It's the hypotenuse. It's the longest side of the triangle. So that means that this side squared is going to be equal to this side squared plus this side squared. So we're looking for AC squared, so we'll write that again. AC squared is equal to AB squared. What is AB squared? It's 3. I just like to use brackets just so it keeps nice and neat. It's not necessary, but I just like to use them. Plus 4 squared. So therefore we bring it down, we note that this is now an equation. So we've now got AC squared is equal to 9 plus 16. Alright, so AC squared is equal to 25. Now you've done equations already. We've had these videos. So if you're struggling with this part, you do need to go to recap and have a look at the video that we posted on equations. Because I don't want to know what AC squared is. So what is the opposite function of squaring something? Square rooting it. So if I have to get AC on its own, I'm going to need to, I'll use a different color, square root that side. But because it's an equation, I need things to balance. Remember we spoke about that seesaw life? I need it to balance. It means that I'm going to have to square root the other side. So now I've got my final answer. AC is equal to 5. And that's that. That's a simple example using the Theorem of Pythagoras. Right, let's keep going. All right, now some of you are sitting there going, well, that's not the example that I saw in class, because I wasn't always having to solve for the hypotenuse. I sometimes got asked to solve for one of the shorter sides. So how does this actually work? Because you told me that the length of the hypotenuse, so we'll use these letters over here. What is the hypotenuse here? It's going to be xz. Using a little xz squared is equal to xy squared plus yz squared. So how am I now going to use this to find the shorter side? But if we were to think about it, if the hypotenuse, which is the longest side squared, is equal to the two shorter sides added together, or squared and then added together, surely, if I was looking for a shorter side, it would be the hypotenuse squared minus the other shorter side squared. So all I'm going to do is write it down like that. That the side that I'm looking for is one of the shorter sides. So if it's one of the shorter sides, all I have to do is, I'm looking for xy squared. So the shorter side is going to be equal to, you've got to write the hypotenuse first, which is xz squared, minus my other shorter side squared, yz squared. And now I simply substitute in the values that I have. So it's now going to be xy squared is equal to xz, right? Xz, which is 10 squared. I'm just going to use no brackets this time to show you that it's going to be the same answer, all right? Minus yz squared, which is 8 squared. So now I've got xy squared is equal to 100 minus 64. So xy squared is equal to 36. Like I did earlier, you've got to square root both sides to get rid of that square sign. So xy is equal to 6. Before I continue, some people will say, well, I've seen my teacher write like this. So from this step here, right, they've said to you that you can actually write it as xy already. Right, now use a different color to not confuse you. So they're writing xy is equal to, and they're square rooting already the xz squared minus yz squared. That is absolutely fine. There's no problem with that. Some people prefer to write it like this. That's why I put it on the board to make sure you don't feel uncomfortable if you do see it. But this is what it is. So there's no difference between the two. Alright, so now looking at it, those are the two different ways that we can be asked this question. So now that we have the tools, I want to take you to that sum that looks almost impossible. The sum you were given for homework and you just couldn't really do it. But you can do it, it's just that we need to look at it for what it is. These are the skills that I need to understand with Pythagoras. Do I have the right angle triangle? Where's my hypotenuse? Am I looking for the hypotenuse? Am I looking for a short side? Are we adding the two shorter sides together? Or are we subtracting the one short side from the hypotenuse to find the other short side? So let's get stuck into that. It's that real tricky sum. Which we're going to make look fairly simple now that we know what we're doing, alright? There's my right angle, and I have my hypotenuse. I have this side over here, this is 6, and I'm looking for D. Right, and they've labeled this. We can label this however we want. So if the teacher hasn't put any labels onto the triangle, you can label it yourself, or you can just go ahead and solve for the sides that you're actually looking for. So if we're looking at this picture over here, what do we see? How many triangles do you see? Well, I see one triangle over here, which is highlighted in the bold black, right? I see another triangle over there, and I see one big triangle. Now, what's most important about this? I know that the small triangle over here is a right angle triangle. I also know that the big triangle is a right angle triangle. But this one here, the bold one, is not a right angle triangle because there's no box in the corner. So I'm trying to get to D. How do I get to D? Well, the process is to try and find all the sides that you can using the theorem of Pythagoras, because we have a right angle triangle. So I could I find, using a small triangle, could I find D or this unknown side? No, because Pythagoras states that I need to know at least 2 of the sides before I can work out an unknown side. Well, can I work with this triangle? No, I can't, because it's not a right angle triangle. So that leaves me with one option, and that's the big triangle. So what is the hypotenuse of the big triangle? It's opposite the right angle, so it'll be 10. So we have the hypotenuse. Do we have either of the other 2 sides, which would be the 2 shorter sides? And I'm going to highlight now them in blue, because this is the triangle that we're dealing with. And yes, I do. I have the length of this bottom piece, because it's going to be 6 plus 2. So it's actually going to be 8 if you add them together. So now that means I can find this side. So let's call this side x. So if I'm trying to find x, boys and girls, what do I know about x, this length? What do I know about it? Well, I know that it's the shorter side. So if I'm trying to find x, I'm going to square it, and it's going to be equal to the hypotenuse squared minus the other shorter side squared, minus 8 squared. And you should be familiar with this, because I gave you an example of these exact same numbers just a couple of minutes ago. So x squared, right, is equal to 100 minus 64. So x squared is equal to 36. I square root both sides, and I'm left with x is equal to 6. Look at that, there it is, x is equal to 6. So what I do, I go and I fill it in. Brilliant. Now all of a sudden, we look and we go, okay, I'm trying to find D. Can I now find D? Well, D, using Pythagoras, is going to be in, let's use orange now, in this triangle over here. That's where D is. And D is my what? D is the hypotenuse. It's opposite my right angle. So do I have the other 2 shorter sides? Yes, I have 6 and I have 6. So that means we can proceed. So we know that D squared, because it's the hypotenuse, I have to square the other 2 and add them together. So 6 squared plus 6 squared. So D squared is equal to 36 plus 36. Therefore, D squared is equal to 72. And now we do the art, we're trying to find D on its own, so we square root both sides. So D is equal to the square root of 72. And I've left it like that because you can pop it into your calculator and tell me exactly what it would be. using my mind though, I know that 72 lies between two square numbers. I know it lies between 81 and 64. Between 64 and 72, there is 8 numbers. And between 72 and 81, there's 9 numbers. So I know it's going to be pretty much 8,5. Let me know if I'm right. I'll say it's probably 8,48. But you tell me if I'm right or wrong. So that's how we solve it. So d is equal to the square root of 72. Something that looks so complex has now made to look so simple. If all we do is we go back, we see what tools do I need in order to solve this. So don't think that I'm just going to leave you here and this is going to be it, because I'm going to give you guys at home a chance to solve a question. And this is what I want you to do for me. I want you to take this down, right? So this is what I want you to take down, and I want you to find the length of CB. What is the length of CB? The one clue I'm going to give to you is, don't be impatient. Don't try and go straight to the answer, because you might fall short. That's all I'm going to say. I'm not going to show you why. All I'm going to say is it involves 2 processes, and that's what you need to do. Once you've found that answer, that's not where you're going to stay. I want you to comment below. I want you to let me know what your length of CB is, and let's see who's the first person to get it. We want you guys to let us know this term if you're getting through this. Is it making sense to you? Because we're only going to go and put more and better videos if this is good enough. But we can only know if you post your comment below. So we need to like this video. We need you to subscribe to Qlicked, so that every time one of these comes up, it pops up. And don't forget that we're giving you exercise in IGTV, and now you're here because that might not have made too much sense to you. This is the full package video on how to solve the Pythagoras theorem. So what's coming up next? Well, we're going to take this stuff and put it boom into the next video, where we're going to be dealing with area involving Pythagoras, that paper 2 stuff that we always seem to struggle with. Yeah, that's what we're going to be doing, giving you some strategies as to how you can become better in paper 2. Because paper 1 is normally that straight down the line stuff. Paper 2 is where you start thinking outside the box, and that's what we are here for. Okay, here at Qlicked, we're here to make sure you understand exactly what's going on. So, at the end of the day, I hope it clicked. It certainly did for me, because I was struggling at one stage, but it all came together. And you know what? I'll see you next time. Have a good one.